Yesterday we discussed about process. We have started process. Some of the states of process we have discussed. Now we will start with one more state of the process which I have not yet discussed. Is my screen visible to you all?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Let me write. So we have discussed start, ready, running, and waiting state. Today we will discuss one more state, that is terminated or exit. Terminated or exit state. Once the process finishes its execution or it is terminated by the operating system, it is moved to the terminated state where it waits to be removed from main memory. So when we can say that the process is in its terminated state, when the process has finished its execution, or there is another condition, or it is terminated by the CPU. So then we can say that the process is in its terminated state. Now let us draw the block diagram of different states of process. I am drawing the block diagram. This is the first state. First state was starting state. We will write as start. Then, sorry, wait. There will be another state, and this state is called a ready state. Here we can see that how the process changes its state from one to another. And the next one is running. You can say it is running. Next is, here we will write terminated. Here there is one more state, we can say, that is wait. wait is another state. Everyone is requested to keep themselves muted. Some noise is coming. Some one of you have unmuted yourself. Since the process changes its state from running to waiting, then from waiting state to ready state, so the arrow is given in all the directions. It is a bidirectional arrow. And after the process has completed execution, that is from running state, it will reach to terminated state. This is the block diagram of different states of process. Now I will ask one of you, whom should I ask? Neha Gupta, unmute yourself. Neha, can you unmute yourself?
Yes, ma'am. Yes, ma'am.
Can you tell me why there is a bidirectional arrow from ready to running? Neha, if possible, please switch on your video.
Yes, ma'am.
I'm asking you to explain the reason of
Ma'am,
why there is a bidirectional arrow from ready to running. Can you switch on your video, Neha?
yes, ma'am.
Yes. Please tell me. Your voice is not coming. It is disturbed.
Ma'am.
Don't know. You have not attended. You have not attended last class.
Ma'am, please.
Roll number 1, Jeet Sen. Unmute yourself, Jeet.
Yes, ma'am.
Can you tell me the answer? Why there is a bidirectional arrow between ready and running? All of you are requested to study at home. If you have not studied or you have not started studying, do so. If there is any confusion, you can ask me at the time of the class or beyond class hours also. Shubhangi Sheth, roll number 8.
Yes, ma'am. Because it is process life cycle.
Yes, that is okay that it is process life cycle, but what I am asking that there is a two-way arrow from ready to running and then from again to running to ready.
Yes.
Why is it so?
ম্যাম আমি বলবো
Yes, please.
একটা হলো
It is cycling.
রেডি থেকে রানিং এ হলো শিডিউলিং
Please try to
ডিসপ্যাচ আর
speak in English. Jeet, please give me an answer in English.
সরি রেডি টু রানিং শিডিউলিং ডিসপ্যাচ আর রানিং টু রেডি ইন্টারাপ্ট
Ready to running is scheduling dispatch and running to ready is interrupt.
রানিং টু রেডি ইন্টারাপ্ট
Okay, okay. Shubhangi, you wanted to say something?
No, ma'am.
Okay. From ready to running, there is scheduling dispatch. That is as per the schedule when the process when one of the process has completed execution, then another process is allocated the CPU time and it changes the state from ready to running. But however, when interrupt occur or when the process is swapped out from the main memory as per the scheduling algorithm, then it changes the state to ready state. So that is why there is bi-direction. Similarly, from there is a cycle, you can say ready, running, wait. There is a cycle formation. Okay. So up to this, is it clear or I need to explain again? If there is any confusion, you can ask, else I will switch to next topic. No confusion? Okay. Then let me start another topic related to process, that is process control block. We will start with another topic, which is process control block, and let us draw the diagram first, then we will start. Here we will start with process ID. Next field is state. Third is pointer. Priority. Program counter. CPU registers. IO information, then accounting information, etc. Other fields. But mainly these are the main component of process control block. Now, let us look into the architecture of PCB. So the architecture of PCB is completely dependent on operating system and may contain different information in different operating system. So for different operating system, it can happen that the PCB, the contents of the PCB is little bit different. The PCB is maintained for a process throughout its lifetime and is deleted once the process is or once the process terminates. So we can say that the PCB is maintained for a process throughout its lifetime and is deleted once the process terminates. Okay. Now let us look into all these information one by one. First, let us talk about process state. So the current state of the process, that is whether it is ready, running, waiting, or terminated. So in process state, we show the current state of the process. So this is the process state. Next is process privileges. What is process privileges? Does anyone have any idea? What do you mean by the privilege of a process? Have anyone heard about the any kind of privilege? Shayan Dash, unmute yourself. Shayan,
Yes, ma'am.
have you ever heard about any kind of privileges related to process?
No, ma'am.
Okay. Chayan? Chayan is present or not? Chayan? Chayan Shaw?
Yes, ma'am.
Yes.
Yes, ma'am.
Have you ever heard about the privileges?
No, ma'am.
So the privileges means the grants or permission for allowing or not allowing. For example, whenever we are assigning a password, we are attaching a privilege with that user ID. Like when you are logging into your machine, not to your PC, but when you are going in an office or you are coming to college, you are doing a lab, you have entered a lab. So there are two types of login. One is administrator's login, another is student login, another third one may be faculty login. Administrator is having all the privileges. He can change the background, the screensaver, the desktop image, everything. But when you are entering as through student login ID, then you are not able to change any of these. Why? Because the privilege or the permission is not granted to that user. So what we can write? We can write, this is required to allow, disallow access to system resources. That is process privilege. Now, next is process ID. Process ID, can anyone tell me what can be process ID, as it is clearly understood from the name itself?
Process ID means, ma'am, we new ready. Process ID means we new ready waiting running terminated.
No, that is not ID. That is not ID. Yes.
I think process ID is some unique ID when process is created.
Very good. Just like in your case, it is student roll number, which is created or which is assigned to you as soon as you go to admission cell and took admission there. Then each and every student is assigned a roll number, registration, and once you do registration through in Makout portal, registration number, then university roll number is allocated to each and every student. That is considered an ID because it is unique for each and every student. Similarly, in case of process also, uh, unique identification for each of the processes in operating system. So we can say that unique identifier, that is process ID. Now let us learn about pointer. A pointer to a parent process. It shows that the process which is currently executing is a child process or is a parent process. When it is a parent process, then its pointer which contain the detail of its parent will remain null because it is the parent's process, it has no other parent. But when you are talking about child process, then the pointer will point to the parent process. So we can say that this is a pointer to parent process. Is it clear to everyone? Is there any confusion in this pointer? Or should I need to clarify?
Ma'am,
Yes,
ma'am, clarify.
clarify. Dolon, have you understood Dolon Vishash?
Yes, ma'am.
Can you explain?
Yes, ma'am. When a pointer points up parent process, then it shows null because it does not have any parent. And when a pointer points to a child process, then it points to the parent process.
Yes, very good. You have understood it clearly. But I am explaining again. Suppose there are two processes. One is parent process, another is child process. So in case of parent process, value of pointer is null because it has no other parent. But in case of child process, value of pointer to a parent process. That means the pointer points to its parent process. This is the significance of pointer. Now, what is the next field? By looking at the diagram, you tell me what is the next field?
Priority.
Priority. No, it's not priority. Next field is program counter. can see that in the diagram also. I have drawn the diagram earlier. When I will give you this statement, you will see. See, priority I am not explaining here. Okay, let me write one line because else you will get confused. Priority. Priority is priority of the current process. This priority field contains the priority of the current process, whether the priority is high or it is low or it is medium. Okay. Now, what was the next field? Next field was program counter. So program counter, it is again a pointer to the address of the next instruction to be executed. Sorry. It is the pointer is the address of the address of the next instruction. Spelling is wrong. Instruction to be executed for this process. That means a pointer to the address of the next instruction to be executed to this process. When a process is currently executing, the program counter is set to the next process, which will be allocated to your process, or which will be allocated after the processing of that current process. Now, next important field. There are several fields in process control block. We are only discussing the important ones.
Ma'am.
Yes.
Hello, ma'am.
Yes.
Can you please repeat? Can you please repeat priority?
Priority.
Because I can't understand.
Yes. Priority means each and every, when you will start learning scheduling algorithm, you will find out that there are some algorithm where the processes are executed based on their priority. The process which is having the topmost priority will be executed first, and the process with next highermost priority will be executed next. So priority is important so that low priority process can be executed later on, whereas high priority process can be executed earlier. Okay.
Okay, ma'am.
Now there is CPU registers. What is CPU registers? Various CPU registers were process needed to be stored for execution for running CPU. Okay. So we can say that where Adrija Visha, stay muted. Where process need to be stored for execution Okay, so this is CPU register. Execution for state is always kept in mind. This is for running state. So when process need to be stored for execution for running state, that means the process is in running state and there are some intermediate interactions or intermediate calculations. So this is the purpose of CPU registers. Student, I am now sharing the attendance sheet. Let me take the attendance of all the students who are present. I think the attendance sheet is visible. Is it visible?
Yes, ma'am.
Yes, ma'am.
Clearly visible?
Yes, ma'am.
Yes, ma'am.
Then all of you watch carefully. Roll number 1,
Yes, ma'am.
2, 3,
Present, ma'am.
4, 5, 6, 7, then, sorry, 7 is absent. 8,
Present, ma'am.
9, 10, 11,
Yes, ma'am.
12, 13,
ma'am.
12.
Yes, ma'am.
अब तो slow बोल रहा है. 13 is present.
12.
12 and 13 both are present. 14, 15, 16, 17,
Present, ma'am.
18,
Yes, ma'am.
19, 20,
Yes, ma'am.
Present, ma'am.
19 and 20 both are present, right?
Yes, ma'am.
19 present.
21, 22, 23, 24, 25,
Yes, ma'am.
25 you are present. Okay,
Yes, ma'am.
wait. 26,
Yes, ma'am.
27, 28,
Present.
29, 30.
Yes, ma'am.
You have taken a lot of time. 31, 32, 33,
Present, ma'am.
Present, ma'am.
Ma'am, 32 present.
33,
33 present, ma'am.
okay, 34,
Present, ma'am.
34, this is your first class. 35, 36,
Present, ma'am.
37, 37, not present. 38, 39, 40,
Present, ma'am.
41, 42, 42,
Yes, ma'am.
43,
Yes, ma'am.
44, 44. Just wait for 1 minute. I have to. Forty-four, 45, 46,
Present, ma'am.
47, 48, 49,
Yes, ma'am.
50, 51,
Yes, ma'am.
52, 53,
Yes, ma'am.
3 present, 54,
Yes, ma'am.
53, this is your first class.
Yes, ma'am.
55, 56,
Yes, ma'am.
57, 58,
Yes, ma'am.
59, 60.
Ma'am,
Yes.
Hello.
rule number 27 present.
Oh, ठीक time है.
Hello. Hello, ma'am.
Yes. Yes.
Ma'am, 38 madam mic টা কাজ করছিল না আমার
38. Devar go. Okay. And you said 27. Wait. "27 Neha Gupta." Okay, I have given the attendance.
Yes, ma'am.
So with this, I'm going to end the class. I will send you the material.